This is Brooke Hedricks for the Contextual Electronics class. In particular, the PowerSwap board, 3.3 volt output. This is a follow-up test from a previous one where there's been some discussion about whether or not the way I have my test set up might be somehow limiting the current. So I've changed my test. I've taken my multimeter out of the loop. So now we have power coming in the upper left-hand corner of the PCB, and on the lower right hand corner all I have hooked up is a DC load. So there's no multimeter now in line to do the amperage on the input side. Right away what I found interesting was without that multimeter there, I'm not seeing even 3.3 volts coming on my output. You can see on the right hand side of the screen the output V/feedback, that 3.2900 volts is what I'm getting on the output right now. You'll notice that's pretty close to what the DC load is showing as well at 3.283. So the input voltage I'm providing is 3.7 volts. So again, I find it interesting that without that multimeter in line to be able to tell us what the amperage draw is, I am not getting up to 3.3 volts. But in any case, I'm going to start increasing the amount of load. Right now I've got zero load that I've added to the output, and I'm going to start increasing it, and we'll see what happens to that 3.29 volts. So we're at 20, 30, 40. All right, we've hit 100 milliamps, and we're just under that 3.3 volts. We're still going to keep going here. So we've dropped down to 3.28. We're at 150 milliamps. Now we're down to 3.27 at 200 milliamps. So at 240 milliamps, we've fallen down quite a ways off our 3.3. So now you can see we're sitting at 350 milliamps. We're all the way down to 3.2 volts on our output. We're still sitting at 3.7 volts to the input. And what I can tell from my power supply is it thinks we're drawing about 430 milliamps into the system, and we're getting 350 milliamps out. Now what I find interesting, of course, if I increase the voltage, and I'll do that up to 4.2 volts, which is where our lithium batteries would kind of start, then things look a little bit better. So hang on. All right, our input supply now is at 4.2 volts, and I'm going to start increasing the load. So you saw what happened when we got all the way up to an amp. So let's bring this down back into our lower range. So we got 100 milliamps, 200, 300, we're down to 3.25, 400 milliamps. So again, around 350 to 400 milliamps on our load, and we're all the way down to 3.2. I mean, that's probably, I don't know well enough about what our needs are, but I think we fell off of what we needed quite a while ago. If I start going backward, I'm guessing 3.28 is probably closer to what we might be able to get away with, and that's down at 200 milliamps. This is about the same thing I saw in my previous tests, about where things kind of start falling off. I'd love to see some other student maybe run these tests and make sure that you're checking the load at the output as opposed to on the input side, and see if you're getting different numbers than I am for at what point the milliamp draw becomes too much for our PowerSwap. This has been Brooke Hedrick for Contextual Electronics course and the PowerSwap board. Again, retesting the 3.3 volt output version to make sure my meter that was checking the amperage on the input wasn't somehow limiting the maximum milliamp output.